Hey everyone, this is the Math Nexus, and today we are going to continue with O level and IGCSE addition mathematics exercise 2.2. And I know this exercise is being extended a lot, but the thing is, it's a really long exercise that requires it, and I can't make lectures more than 1 hour. It's too much time for me. But let's just jump in and start with it. So for question 6A, and by the way, if you do not know, I've explained the previous 5 questions in the previous lecture, and I would prefer you see the introductory video because that's where I explain the main concept. So please do watch that, and I'll continue with this question 6 and all, assuming that you know everything and you have watched my previous lecture. So question 6A, 5 minus 2x minus x squared, sorry. So we have to make the coefficient of x squared 1, no matter whatever the coefficient of it is. So minus as the common x squared plus 2x, we are going to switch up all the um, we are going to switch up the sign for the 2x, and what we are going to do is finish this bracket and add a positive 5. And the reason why we are not taking positive 5 in consideration is because we do not necessarily need it to make up our this form. Okay, so we do not need necessarily 5. What we are concentrating right now is the coefficient of x squared and the coefficient of x itself. So no need for this one. So what we do next is minus x squared plus 2x as it is, but we are going to add up 2 divided by 2 is negative, sorry, it's positive 1. So plus 1 squared. And what we are going to do is, in order to balance this equation, we are going to subtract this 1 squared, then plus 5. Then to sum it up, x plus 1 whole squared, and this minus 1, in order for it to be independent, it has to be multiplied by this negative sign. So it will become minus 1 squared multiplied by negative. So it's going to be positive 1 plus 5. And that's going to be 6 minus x plus 1 whole squared. I've added these up and put it behind this negative sign. So that's it. This is for question 6A. It's really easy for now. In part B. So 8 minus 4x minus x squared. So again, we have to do the same thing. The negative has the common x squared plus 4x and plus 8 out of the bracket. So we are going to say minus x squared plus 4 divided by 2 is 2. So we are going to say plus 2 squared. In order to balance this up, we have to subtract negative 2 squared plus 8. Similarly, we do it again, negative x squared, sorry, my bad, not x squared. Negative x plus 2 whole squared minus 2 squared is 4, negative 4 multiplied by negative, as I've discussed in the first part, will become positive 4. Positive 4 plus 8, and 8 plus 4 is 12, and 12 minus x plus 2 whole squared is equals to our answer. And that's it. This is for part B. For part C, what we're going to do is a line here, C 10 minus 5x minus x squared. Again, what we're going to do is make the coefficient of x squared 1. So negative as the common x squared plus 5x. We do not need to take in consideration this 10, so we are going to write this separately. So negative x squared plus 5 is x is going to be written as it is, but 5 divided by 2 is 2.5. So plus 2.5 squared minus 2.5 squared and plus 10. So again, minus x plus 2.5 whole squared. What we are going to do next is take this negative up, and the negative 2.5 squared multiplied by negative is going to be let me just see, 2.5 squared, 0.5 squared, that's going to be 6.25 as a positive plus 10. And well, 16.25 minus x plus 2.5. Oh my god, I'm really sorry, I wrote 2.25. 2.5 whole squared. And that's our answer for part C. And again, I'm going to emphasize that you watch my previous lectures if you don't understand what I'm doing right now, because that's going to be. And for those of you who do not know, let me just explain this part really quickly. What we're doing in this is we put this in the form x squared plus 5x plus 2.5 squared. And what we're basically doing is putting this in the form a squared plus 2ab plus b squared. And if we get this form as we've done here, what we can do is make this into a plus b whole squared. And this will allow us to reach the desired form that have been asked us in the question. That's what we are doing for now. Just a really quick reminder, if you want to know this in detail, just watch my previous lecture. So 7 plus 3x minus x squared. Okay, so what we do now is take negative as the common again. Negative x squared minus 3x. We do not need 7 necessarily, so just ignore it for now only. So negative x squared minus 3x, 3 divided by 2 is 1.5. So plus 1.5 squared. And in order to neutralize this equation, you have to subtract 1.5 squared also. So plus 7 minus x squared. Again, I did this. I'm really sorry for that. So x minus 1.5 whole squared and minus 1.5 squared multiplied by negative so that it can be independent of the bracket it is trapped in. So that will become positive 1.5 squared plus 7, and that is going to be plus 9.25. And if we rearrange this 9.25 minus x minus 1.5 whole squared, and that's our answer for part D. Okay, this is for question 6. Proceeding to question 7. So what we have here is we have to express or express each of these followings. I'm sorry, what I'm saying. Express each of these following in the form a minus b x plus q whole squared. So what we are going to do is say question 7, part A, 9 minus 6x minus 2x squared. And again, I'm going to remind you to um, make the coefficient of x squared 1. That's the most basic first step you have to do, no matter what. So negative 2 x squared minus, we have taken 2 as the common, so 2 3 is 6 plus 3x by the way, and plus sign. We are not going to take 9 in consideration for now. So negative 2 x squared plus 3x as it is, plus 1.5 squared, 3 divided by 2 is 1.5 minus 1.5 squared plus 9. Okay, and what we're going to do next is, so negative 2 x squared plus 3x. Oh, I'm really sorry. Just repeating these steps. So negative 2, wait a second, x plus 1.5 whole squared, x plus 1.5 whole squared, minus 1.5 squared multiplied by 2. So sorry, 1.5 squared multiplied by negative 1.5 squared multiplied by 2. That will become positive 4.5 plus 9. And if you just take this 4.5 plus 9 is equals to 13.5 minus 2x plus 1.5 whole squared. This is after rearranging the equation. Okay, similarly, for part B, we have 1 minus 4x minus 2x squared. What we're going to do is again take negative 2 as the common, x squared plus 2x, 2x and plus 1. We're not going to take 1 in consideration. So what we do next is simply take negative 2 x squared plus 2x plus 2 divided by 2 is 1. So 1 squared minus 1 squared, and plus 1. So negative 2 x plus 1 whole squared minus 1 squared multiplied by negative 2 will give us positive 2 plus 1, and that will be 3 minus 2 x plus 1 whole squared. Okay. Yeah, so that's it. Let me now proceed to part C. So for part C, we have 7 plus 8x minus 2x squared. And what we do, again, as we've been doing till now, we are going to take negative 2 as the common, x squared minus 4 is 8, so 4x, and 7 is going to be out of the bracket for now. So what we do next is negative 2 x squared minus 4x. 4 divided by 2 is 2 itself, so 2 squared. In order to neutralize this equation, we have to add a negative 2 squared plus 7. Negative 2 x minus 2 whole squared. Negative 2 squared is negative 4. Negative 4 multiplied by negative 2 is positive 8. And that's going to be added into 7. So 7 is 15. 15 minus 2x minus 2 whole squared is our answer for this part. Okay. And as you can see, these are really the same thing repeating more and more and more. And you just have to master the basic concepts, and you're going to find the questions are going to be really, really easy for you. So 2 plus 5x minus 3x squared, and take negative 3 as the common, x squared, and plus, wait a second, minus 5 upon 3. So what's 5 upon 3? Oh, I'll just take 5 upon 3 as the, so x squared minus 5 upon 3x. 5 upon 3 divided by 2 is going to be plus 5 upon 6 whole squared, minus, in order to neutralize this, we are going to say minus 5 upon 6 whole squared, and that is going to be added into 2. And what we're going to do next is negative 3 x plus, and oh sorry, x minus 5 upon 6 whole squared minus 5 upon 6 squared. Let me just see. What's 5 upon 6 squared minus 5 upon 6 squared multiplied by 3, which will make it positive 25 upon 12, and that is going to be added into 2. So we are going to get 49 upon 12. So plus 49 upon 12, and that is 49 upon 12 minus 3 x minus 5 upon 6 whole squared. And if you want to write this 49 upon 12 in another form, you can write, I just use the calculator to find this out. 4 whole 1 upon 12 and minus 3 x minus 5 upon 6 whole squared. It's really messy in the end. Let me just clean this up. Okay, x minus 5 upon 6. Okay, so that's it. This is for part 7. And let's proceed to part 8. Question 8 actually. So for question 8, we at last a word problem. I do not at all like the questions which have multiple parts in them, because they're like same thing repeated twice or more than that. So the thing is, for question 8, 4x squared plus 2x plus 5, we have to write those in the form ax plus b whole squared plus c, where a, b, and c are constant. And by the way, many people get confused what's a, b, and c are constants. It's nothing, they're just hinting you that these are going to be uh, numbers. They are going to be numbers that can't be changed. So they're not variables, they're not x, y, c. They're just telling us that this is going to be, instead of a, b, c, our answer should be in the form of numbers. So Really simple. 4x squared plus 2x plus 5. What we're going to do is take 4 as the common, as we've taken. So 4 as the common, x squared plus 2 upon 4 is going to be 1 upon 2x, and that's going to be plus added into 5. So what we do next is 4x squared, and so I'm really sorry, I just did x squared again. X 4x, um, you know what, it was necessary. 4x squared plus 1 upon 2x, plus 1 upon 2 divided by 2 is 1 upon 4 squared minus 1 upon 4 squared plus 5. By the way, I'm really sorry. I was just in between. I don't know what I did because I was confused. So what we are going to do for, we are going to factorize this up, you can say. So x plus 1 upon 4 whole squared minus 1 upon 4 squared. Um, that's going to be 1 upon 4 squared, answer squared, 1 upon 16, yes, multiply by 4, and that's going to be 1 upon 4. And again, what we are going to do is we are going to write this 1 upon 4 negative 1 upon 4 plus 5. And what we are going to say is negative 1 upon 4, 5 minus answer, we are going to get 19 upon 4, or we can write 4.75. I'll write 4x plus, and 1 upon 4 is 0.25. So 4x plus 0.25 whole squared plus 4.75. And that's for question number 8, part A only. And let's go for part B. What we're going to do is, does the function y is equals to 4x squared plus 2x plus 5 meets the x-axis? And what they're basically asking us is, we have to tell if this is, joining at the x-axis. So it's really simple. What you do is, when is the x-axis coming in a graph? So the x-axis occurs when y is equals to 0. Now explain this. If you don't know, this is really basic math. When x equals to 0, we have the y-axis, and when y is equals to 0, we have the x-axis. So what we do is really quickly say 4x squared plus 2x plus 5 is equals to 0. We have to solve this equation. Like what we are going to do is a is equals to 4, b is equals to 2, c is equals to 5. I'm using the quadratic formula so that it's much more easier to explain this. Wait a second, let me make a really clear line. So that's minus b, so that will be minus 2 plus minus under root b squared 4, meaning minus 4 multiplied by a multiplied by c. And for those of you who are really good in maths, I mean, who practice a lot, I think most of you would know the error has come in this part only. So divided by 2 multiplied by a, what we are going to do is really quickly, I'm going to simplify this. Minus 2 plus minus under root 4 minus 4 is a 16. 16 multiplied by 5 is 16 multiplied by 5 is 80. So 4 minus 80 divided by 4 to the 8. And again, minus 2 plus minus under root 4 minus 80 is going to be 76. Yeah. So it's going to be negative 76 divided by 8. And now most of you would have noticed that this is a negative 76 inside an under root. And the thing is, whatever, if we have a negative sign inside an under root, whatever it is, it's a negative value, then our solution will be not applicable. And the thing is, a math error will occur. And that's because whenever there's a negative value inside an under root, it's going to be wrong. It's wrong. it's defying the laws of mathematics, you can say. So it's that thing. So we are going, and even if you want, try it in the calculator. And input -76 in an underwood, you'll get math error. So what we are going to say is, for part B, we are going to say, no, this function um, does not meet the x axis, as um, an error will occur if we try to solve the equation accordingly. And what I mean from this is, if we will try to solve the equation accordingly. Yeah. So if we try to solve this equation according to the method, I mean, according to the value of y to be 0, we'll get a um, answer that the graph is not meeting the x-axis. I hope I'm clear for now. So that's for question 8. Let's proceed to question 9. Okay, so for question number 9, we basically have the equation 2x squared minus 8x plus 1. Then what we are going to do here is, for part A, express 2x squared minus 8x plus 1 in the form ax plus b whole squared plus c. Really simple. What we are going to do is take 2 as the common, x squared minus 4x, and we are going to keep the 1 aside for now. So again, expand this up, x squared minus 4x plus 4 divided by 2 is 2 itself, 2 squared minus 2 squared to balance this up, and again plus 1. So next we are going to factorize this up, x minus 2 whole squared minus 2 squared multiplied by 2 is going to be negative 4 2s are 8. So it's going to be negative 8 plus 1. And similarly, 2x minus 2 whole squared minus 7 is going to be our answer for question number 9. Similarly, what we are going to do is, for part B, find the coordinates of the stationary point of the graph for which y is equal to fx. And basically what they are saying here is, find the coordinates of the in this case, the minimum point for which we take the function of f to be the y value. So simple, I've discussed in the previous lecture the equation ax minus h plus k, and where the h value is the, ax minus h whole square, where the h value is the x value of the stationary point and the k is the y value of the stationary. So if you don't understand, please watch my previous lectures. I've explained this in it. More specifically, the lecture in which I start exercise 2.2. Or no, not that lecture. The one that was just before this one. So that's it. So what we're going to say, x minus h. So minus 2 is here, but it's x minus h. So we are only going to say, we can say negative h is equal to negative 2, and we cut down these two negative and negative signs. So the x value is 2 for the stationary point, and for the y value we have negative 7, as we are comparing it with k, positive k. So that's it. This is the stationary point. So as for question number 10, what we have here is x squared minus x minus 5. So let me just really quickly copy this question. Fx is equals to x squared minus x minus 5. Okay. And we have to find the smallest value of fx and the corresponding value of x. What this is saying is, we have to find the smallest value of x. That is actually the most minimum value of x. I mean, from what I mean is the stationary point. And how do I know that the stationary point is actually the minimum value? That's because the coefficient of x squared is greater than 0. Okay, oh, sorry. Coefficient of x squared is greater than 0. And when it's greater than 0, we have a smiley face. When there's a smiley face, we have a minimum point. So for how can we find the minimum point, we have discussed in the previous question by bringing it to the form we want. So x squared minus x minus 5, what we'll do is x squared minus x plus 1 upon 2 squared minus 1 upon 2 squared and minus 5. Okay, so that's going to be, after we prep this and factorize this, x minus 1 upon 2 whole squared minus 1 upon 2 squared and minus 5. 1 upon 2 squared is going to be minus 1 upon 4, and minus 1 upon 4 minus 5 is going to be minus 5.25. And that's it. So how do you find the maximum or the minimum point? Well, that's going to be actually the minimum point in this case. And as we have discussed, a x minus h squared plus k, we have this equation for the most smallest value of fx. So the most smallest value of fx is going to be actually the most smallest value of the y-axis, because we are taking fx to be on the y-axis. So negative 5.25 is the most smallest value of fx, and that's negative 5.25. And for the corresponding x value, as we can see, wait a second, x value, as we can see, for the y value, what is the x value? It's 0.5, and I've discussed negative h is equals to negative 0.5. Negative 1 upon 2 is actually negative 0.5, for those of you who do not know. So we cut these down, and the corresponding x value is 0.5. That's it. These are the two corresponding points. And now there's a really interesting question, and I need some space. What they're telling us is we have to write down a suitable domain for which the function f for which the inverse of the function f exists. And for that, just give me some time. Let me just go back to the graph where I have a parabola. Wait a second. Bear with me, please. It's just here. So the thing is, we have a parabola. And what they're saying is, for example, let me tell you. If we take the y value to be 2, so for example, y is equals to 2. We take this up. This is, for example, y is equals to 2. And we make a line here. So we are getting two values of x, and that's what we are doing. For the parabola, we are going two values of x for one value of y. And that means from one input, we are getting two outputs. And that means we are having a one-many mapping. And as we've discussed in the earlier lectures, towards the starting of the functions chapter, even chapter 1, we discussed that the inverse of a function does not have one-many or many-one mapping. Inverse can only exist when a function has a one-one mapping. Okay, and the thing is, now let me ask you, what is the thing that may make this parabola a one-one mapping? And the answer for many would be really simple. We would just decline this. We would just cut this side of the parabola. And what that would mean, for one y value, we would only one x value. Okay, if we cut this, I'm really sorry. I'm really being rude with the graph. But the thing is, if we ignore this part of the graph, now let me. So, and we take y is equals to 2, we only get one value, and that would mean that this is a 1-1 function. So, actually, what we want, and for this thing, we want to divide the graph exactly into a half, so that there's no compromise or there's no incorrection in the graph. So, what we do is take the most minimum value of x or y, meaning the stationary point. We take the minimum value of x, or you can say this value of x, through which the graph is, the parabola is being half down, it's just been cut into half. So we take that station, we can say that is the value of x when there's a stationary point. So we take the x value of the stationary point, and we say before it, we are going to cancel it, and after it we are going to consider it. That would make us a one one mapping. Okay, for And now I'm going to explain it again. The thing is, we want a one-one mapping, and for that we have to ignore half of the graph we have. And for that, we cut down the value. We take the stationary point of x, meaning the x value of the stationary point, because that's the point where the parabola is being exactly broken into half. And we say that before it, we are going to ignore the x values, and we are only going to take the parabola after this x value. And that would mean for one y value, we would only get one x value, meaning a 1-1 mapping. And when there is a 1-1 mapping, the inverse of that function can exist. So back to our question, let me be real quick. 6, 7, please bear with me, I'm really sorry. Yeah. So for the suitable domain of f inverse of x, what's the most minimum corresponding x value? We have 0.5, meaning that's the minimum point of the parabola. So we can say that when for this is part B, when x is greater than or it's equals to 0.5, the inverse can exist, and that's it. Okay, that's the point. Whenever the graph is greater than this 0.5, the parabola will have a 1-1 mapping, and we can say thus it is suitable for the f inverse to exist. So that's it. This is today's lecture, and I'll complete. I think yeah, 6 questions are enough to complete in the next lectures. So I'm going to complete exercise 2.2 in the next lecture. Till then, bye, and I'll meet you in the next lecture. Thank you.